Talk or something like that. So it's like a walkie-talkie, and
what? I didn't catch that.
hello.
Hello.
How's it going?
Y'all second day of classes, and I'm still here, so it can't be all bad.
Are they watching us? And then there's a teacher. So, someone waves to go with that. Oh, he's smiling. He's smiling. There it is. What is going on? Okay, so are they?
How are you all? What's that? Are you confused? Am I confused? Yeah, we're not confused. We're all right. Correct. Yeah, for today.
Maybe they think her full class ahead. Really?
All right, well, good morning. Okay. Hi, Rob. How are you doing? Thank you. Okay. So some people in here are saying they're a little bit confused. I don't think they're confused anymore because I just walked in here, so I think we're all good now. My name's Jamie McGill. I'm going to be teaching this class. So I see we have two there, at least that I can see in Kingsport. I think we have 4 or 5 on the roll. So we are being broadcast to Kingsport. That's what's happening here. And I am here, obviously. I am going to try to get to Kingsport at some point during the semester. I don't know when. Excuse me. I do have a class that meets not right after this, but pretty close after this. So I'll have to see what I can do because my class that meets is here on the ETSU Johnson City campus. Okay. So I will at some point venture over to Kingsport, and then you guys here will be watching me on the screen. So it's important to note all of you can talk and all of you can be heard. So you have little microphones in front of you on your desks, so whenever you want to ask a question, you just press the button on your microphone and ask it. And whether you're here with me or there, you need to press the button on your microphone, okay? If you're here with me, even though I can technically hear you if you do not, I would like for you to pretend that I can't hear you if you do not press your button, because the only way that they are going to hear you is if you press that button. And we're all one class in together, okay? So that's what we need to do, is be able to do that. Here in a few minutes, I'm going to go through the class roll that I had printed off before I came over here, and that will give you an opportunity to practice pressing that button to answer that you are here, okay? So that everybody will at least know what they're doing. I don't think it's anything too difficult, but that way at least you'll say, yeah, I know what I'm doing. When I want to ask a question, I've just got to hold that down. So that's the only thing that's really a little different maybe from some of your other classes, okay? All right. Today what I want to do is first, I would like to talk about the syllabus. I want to go through the class roll. We might have a little bit of time to start into chapter 6. That's where we start in this class, is chapter 6, okay, in the textbook. The textbook looks like, well, this is what my cover looks like. Now, you all, I think, get a loose leaf version if you buy a textbook, so you're just going to look a little bit different. I would like the loose leaf version, but they won't give me one, so from the publisher. So anyway, that's what the textbook looks like, but we're going to talk a little bit about the textbook, the Mymathlab. I don't know if you all have had a chance to look at the syllabus yet or not, but I always like to talk about it in class just to make sure that we all understand what's going on, okay? All right, so let me pull the syllabus up here on the screen. And there we go, okay? This is posted on D2L. I didn't print off copies for you because it's there on your site. Okay, you can print yourself off a copy if you would like to have a copy of it, but I try to do a lot of posting onto D2L, anything like this that I use, so that it's just there for you to access, okay? Is everyone familiar with D2L? Everybody's been on their D2L site, and you do see you have this class on there? That's great then, perfect. All right, I've already told you my name. My phone number's listed here. My office is over in Gilbert Hall here on the ETSU Johnson City campus. So Gilbert Hall is not too far from this building that we're in here. So you all, if anybody needs to know where that is, let me know. Okay, you may already know. And I'm in room 308, and we all have letters on our doors, and mine is letter O. Okay. My email address is there, which I know you all also have access to through your D2L site and so forth. My office hours are listed 10 to 11:20, 9:45 to 10:20 Tuesday, Thursday. So also, you know, usually right before class, right after class, those are good times to catch me. Actually, one of these sets of office hours is right after our class, but normally I will try to get over here a little bit earlier than what I did today to get here. I have 4 kids. They all got off to school this morning. Okay, that's a good thing, right? So one of them's a student here at ETSU. The other 3 are here on campus at University School on the campus, and they start at 8 o'clock. So technically I should be here, you know, at least by 8 and get on over here. So we'll see how that works out for us. All right. The textbook, I told you what it was called, but then I've got starred down there, Mymathlab. Okay. Mymathlab is an access code. Well, what you'll need to purchase is the access code that gives you access to Mymathlab on the internet. Okay, it's an online site put out by the publisher. If you want to just have the Mymathlab part, then you don't have to have the physical textbook. That's fine with me. Okay, for my purpose, you don't necessarily have to bring a textbook to class. I would recommend you have one. I'll be giving you some problems to work with, some homework type problems, suggested problems. If you don't practice them, you're going to struggle in here. That's just the bottom line. So whether or not you have that physical textbook is up to you. because on the Mymathlab you have access to an ebook. The ebook is exactly like the physical textbook, okay? So it's up to you how you want to purchase that. I need for you to have the Mymathlab though, because I'm giving you some assignments on there to that will be graded through that program, okay? So I'll be setting up some assignments on there for you to use throughout the semester that will count as part of your grade. So you need to purchase that. You can purchase the Mymathlab access code through mymathlab.com. Okay, you can go in and we'll look at that site in just a moment and tell it you want to register as a student, and it will give you a chance to buy the code if you don't already have it. So of course you'd have to have a credit card and that kind of thing. They also sell the code at the bookstore here on campus, as well as the one down on Walnut Street. There's two bookstores on Walnut Street. There's Nebo behind the McDonald's, and across the street from McDonald's you have the Student Book Exchange. So you can get it there, or you can get it online. Like I say, online may be the easiest for some of you. I don't know. But you'll need this course ID that I've got up here, McGill 46173, so that when you register on Mymathlab, you're registered into this class. Okay? You'll need that code. All right. What else do we have here? These are the topics we cover. We're going to start out talking right away about trigonometric functions. This is a trigonometry class, so our focus is throughout the semester on trigonometry. We talk about the functions themselves. We talk about how we're going to use some of those, some formulas we use, some right triangle trigonometry, and then we go into a preview of calculus where we just kind of do an overview of the concept of a limit. Okay, some of you will be going on into calculus, I assume. Some of you are going to calculus. Who's going to calculus? Okay. Some of you are going to calculus 1. Some of you are going to the, what's it called? Now I can't think of the name. The technical calculus course. It's listed as Math 1840. I can't think of the name of it. Technical calculus, I guess. I don't know. And anyway, it's too early in the morning maybe for that one. But a lot of engineering, surveying, construction engineering majors take the 1840, and let's see who takes the calculus one, the 1910 class. Probably if you're I don't know, math major, science major, pre-med, that sort, right? So anyway, whatever path you're going to, hopefully that preview of the limit will help you a little bit as you start into that calculus course. Whichever one you take, you will be talking about the limits, okay? So that should help you out a little bit. If you are not going into one of those classes, I guess it's just free information to impress your friends with. Is that right? When we get there. The rest of the time, though, we're doing a lot of trigonometry. Trigonometry, what do you think about with trigonometry? What does trigonometry make you think about?
Triangles.
Triangles, right. Triangles is one thing we think about with trigonometry, because probably if you've studied trigonometry at all in the past, and I bet some of you have worked with right triangle trigonometry. Some of you know that as the SOHCAHTOA stuff. You know SOHCAHTOA, right? Okay, some of you may have other names for that one. In here we will be talking about right triangle trigonometry, but that's not where we're going to start. However, if you already have a concept of that, then I'm sure you'll be able to use that to help you along the way. What else do you think about with trigonometry? Does it bring anything else to mind? All right, it's still early, but how about like sine, cosine, the actual trig functions, right? You think about those and how they relate. So if you have studied trigonometry before, you probably have some idea of those. Some of you have never studied trigonometry. I am aware of that as well, okay? We'll approach it pretty much from that standpoint. So there are some things, that if you're not sure about some of the algebraic concepts, I want to go ahead and mention, there is a class that precedes this one. There is a class. I'm not trying to get rid of anybody. Don't think that. But I have to tell you, there's a class that does the first part of the book. So if you haven't done that class, you might be interested in it. If you're a little bit unsure about starting right off into trigonometry, there's a class that does chapters 1 through 5 of the book. It's called Precalculus One Algebra. Okay, it's not just the basic algebra, but what it does have in it is a study of a lot of different functions, linear functions, polynomial functions, rational functions, exponential and logarithmic functions. Some of you have probably taken that course as well. But if you have not and you feel a little sketchy, you might want to drop back to that. Okay, just a thought there. We'll look at some of algebra concepts here in a little bit that hopefully you have some idea of coming into the class, or that I'm assuming you have an idea of, and if you don't, you might want to at least review those. Okay, so I'll bring those up here toward the later part of class. Okay. All right, so here's the basic list of topics. These are listed by the chapters in the textbook. So we start with chapter 6. You do 7, 8, and part of 14 there. Homework, I assign homework, but I don't take it up for a grade. As far as what I give you in class, I'll say, you know, try these problems. Toward the end of every class, I'll say, try these problems from this section. I'll give you some to try from each section we do, because like I said, you will need to practice. Math is not a spectator sport. You can come and sit in class. You can be here every day. You can watch me do problems up here. You can listen to me tell you how to do problems. That does not mean you can do the problems. Very few people can do them that way. Okay? You need to practice. So I can't stress that enough. You will need to practice away from here as well. Okay? At the beginning of each class, I'll give you a chance to ask questions about the previous homework assignment, so that, you know, we won't go over the whole thing. We don't have time to do that, unfortunately, but what we'll do is try to hit some highlights from the previous assignment. I normally hit a few problems, try to just, you know, kind of redo a little bit of the information from the previous class so that we can get it in our heads a little bit better. So it's really helpful if you do the homework or try the problems and then know what you're struggling with when you come back in so that you can ask about it. Okay? You will have graded assignments on the Mymathlab. All right, tests and quizzes. We'll have 3 in-class tests. There'll be paper pencil tests. Okay, so several, and I've got this all listed together: quizzes, homework, Mymathlab grades, and a comprehensive final exam. Please plan to attend class when the tests are scheduled. If you miss a test due to a documented unavoidable circumstance, documented unavoidable does not mean I couldn't get up this morning because I stayed out too late last night, right? Not things like that, okay? But if there's something real, we'll say something real, all makeups have to be taken before I return the test to the class. That will normally be within 2 class periods, okay? If we take a test on a Thursday, I should have it back to you on the following Tuesday, so which would be 1 class period. If you take a test on Tuesday, you might not get it back till the next Tuesday, okay? Just depending. Okay? So just so you have an idea. If we do have any in-class quizzes, I will not do makeups on those, okay? But as far as the test goes, if you do know ahead of time that you're going to have to miss on a test date, you need to talk to me. Okay, communication is a very important part of us working together here. In this class, we'll have 3 tests. We'll have a quiz/homework average. Those go together. That includes that Mymathlab stuff. It counts 20% of your grade. And the final exam, which is also 20%. The final exam is comprehensive. Let's see, what else here? Attendance. You know what all this says? I want you to be here. Okay? That's what it says. You need to be here. You're registered for the class. You need to be here. That's all there is to it. There's a sign-in sheet back at the back, and you all have one in Kingsport as well, so sign in and let me know that you're here when you come in every day, okay? I like to keep up with that. I don't necessarily take off if you are not here. That does not mean I don't care if you're not here. I do care. It does let me know, you know, if you are participating, trying, giving some effort, that sort of thing. Okay. If you have to be out for any extended period of time, please also let me know that. Again, communication. I love communication. Okay? So let me know if you have to be out for an extended period of time. Try to keep up if you have to be out. Don't just drop off the planet. You know, sometimes people drop off the planet, and I don't know where the students went. So Keep up if you're out. This class makes it really easy for you to keep up when you're out. Every class is recorded. You can access the recording. You've got directions on your D2L site how to get to that recording. So if you miss a day, you can watch it later. Okay, get you some popcorn or something, you know, I don't know. You might need that to stay awake watching it. I don't know. You know, it's not like, you know, the adventures of Precalculus. So anyway, it's there for you. It's a help. It's very easy for you to follow along. Another thing I do is when I write notes up, I save the notes in a PDF file and post those on your D2L site as well. So the notes that we took in class, the notes I wrote out in class, will be on D2L as well, unless I forget and X out or have some other technical difficulty. That happens occasionally, and then we might miss a day. But normally I post your notes on D2L, and you have the recording there as well. Okay. All right. Makes it easy for you to keep up. Calculators.
Hey, Jamie?
Yes. Uh-huh.
Hi.
Hey
Hi.
there.
David, I'm your proctor over here.
Hey, David.
Hi. We don't get D2L. I mean, the proctors don't. So if you put a note in there like a cancellation or something like that, would you let the ITV people over there know and they'll pass it on to me?
Yes, I sure will. Yes. And
Thank you.
I wonder if there's a way, well, you don't want all my D2L notices. I started to say I might could add you to my D2L site. I don't know. But I'll check. I'll definitely make sure you know, okay?
Okay. Yeah, that'd be fine. Whatever you want.
Okay, thanks. Normally, on that note, I don't cancel class, so just for the record. And so Andrew says I can add him, and so that way you will know for sure. So I'll add Andrew in.
Yeah, you let Andrew know. He'll definitely let me know. So
okay,
that's fine.
great, thanks. Normally I do not cancel class though. Occasionally I might be running a few minutes late, so I'll just tell you up front that I'm going to be here. Okay, if I haven't let you know ahead of time, I'm going to be here. I don't live far away. We're probably not going to get snow this semester. Okay, it's not out of the ordinary too. We could toward the end, but usually the snow's more in the spring semester. Anyhow, even if we get snow, I'm normally here. Okay, I don't live that far away. I've got a 4-wheel drive car. I'll be here. Okay, the only thing that keeps me out is if I have a sick kid. One of my younger kids gets sick, something like that. Okay, and we're going to hope that doesn't happen. All right, so if you plan to use a calculator, please bring your own. And I know that sounds like common sense. Things like that I put on my syllabus, I put for a reason. You know, that means I've had some experience with that before. People ask, sometimes a student will ask another student, can I borrow your calculator? And they say, yeah, sure, you know. There's been times that it's been very obvious the person has not really wanted to share their calculator. Okay, well, because they have to wait on the person to finish, right? You know, they want to use it themselves. Bring your own calculator. Don't rely on someone else. Okay, they really don't want to let you borrow it. I'll just tell you for them. Okay, they don't want to share. All right, and the scientific calculator is all you really need for here. But if you have a graphing calculator already, that's fine. That's no problem. You can use that as well. You cannot share calculators on exams. You cannot use cell phone calculators on exams. In fact, when we take tests, I don't even want to see cell phones out. You are good anyway, because I don't see any cell phones out right now. So most of you, I'm sure, have cell phones, though, and just try to adjust them so that they're not ringing out in class. You know, occasionally we have times we forget that happens. I understand that. But try to think about that beforehand, adjust it so it doesn't, I say ring, beep, yell, or sing, because we have so many different ringtone choices, so that it just doesn't cause a disruption during the class time. If you do have to answer a call, you know, you get a call during class and maybe you have kids and it might be their school calling or something. You got to answer, right? So just go out in the hall and answer, you know, as quietly as you can. That'll be fine. So don't answer in the classroom. Again, I'm saying that for a reason, believe it or not. So, all right. I guess that's pretty clear on that. On the first two tests, calculators may not be allowed. First test for sure, we're not going to use a calculator, okay? So I'm telling you that up front. Second test, I haven't made up my mind yet. Okay, that's a little bit off still yet, but I'll let you know in plenty of time. Anytime we're going to have a test, I'll let you know at least a week in advance, usually a little bit more than a week in advance. I'll let you know that test date. I don't have them set out today, mainly because I can never stick to the plan. If I do that, something will always happen to mess up my plan. If I say, oh, we're going to have a test such and such date, it usually doesn't work. I'll tell you at least a week in advance. Okay, is that enough notice for everybody? Yeah, okay, good. The grading scales on here, we use the plus minus grading scale, and there's the scale that's set up for us. Tutoring, we have tutoring here in the Center for Academic Achievement over in the shared library. And on the Mymathlab, the access stuff online, there's also tutorials. There's an available tutoring service there you can access or call in and talk to a live person even. Okay, there's lecture videos there for every section in the textbook. There's PowerPoints on there. It's got a lot of helpful things if you explore and find those things. Some of you will just go in and do the assignments I set up, and that's okay too. Some of you will go in and know everything about, where all the helpful stuff is, and that's good too. So however you learn best is what you want to do, The hours for the CFAA are up here Monday, Tuesday, Wednesday, Thursday. They're open from 9 to 9, Friday 9 to 3. Closed on Saturday. That's kind of interesting to me, but anyway, Sunday 3 to 9, and that's the website for the CFAA because they like for you to set up an appointment if you're going to come in for one-on-one tutoring. Okay, that's not to say you can't walk in and get help. Usually you can walk in and they'll have somebody to help you, or they'll put you with a group of people working on the same class. But if you really want to make sure you get one-on-one tutoring over there, you need to call and make an appointment, okay? Final exam will be on Tuesday, December 9th, from 1:20 to 3:20. Please note that this is not at 8:15, okay? So some of you may need to make arrangements for that different timing. Final exam week's always different. The final exam schedule is already set up for the university, so if you're wondering about your timing, just go to the home page for ETSU and type in the search bar final exam schedule, and it'll bring it up for you, okay? Does anybody have a question about the syllabus or about the class in general? Yes, go ahead. Thank you.
So I won't need a calculator? It's like an optional thing?
No, a calculator is not exactly optional because there will be some things we do where you will need one, okay? So on the first test, I'm not going to let you use one because everything on the first test revolves around the unit circle and the basic trig functions. And those are things I need for you to have up here in your head, especially if you're going on into calculus. You want those things here, and you don't want to be calculator dependent for that, okay? But there are other things we'll do with some formulas and stuff where you'll want to have one. Okay. Go ahead.
Do you mind if I write a note of that on my phone? Just write a note.
No, that's fine. You can go ahead and do that. Yeah, that's fine. And so any scientific calculator is okay to use. And I say that because I don't want somebody to think they have to go out and spend a bunch of money for a graphing calculator, Like I say, if you already have a graphing calculator, that's fine. You might want to bring it in and use it just, to get more proficient at it. Maybe some of you are very proficient already on those. I will try to, guide you if at all possible if you have a question about using your calculator. Some I know about more than others, but, the scientific ones work pretty similarly. I would recommend, though, if you don't have a calculator, that you get one just so that you're not walking through the hallway and saying, hey, I've got a test. I need to borrow your calculator. And then you get it and you don't really know how to operate it. Okay? I know that might sound crazy, but you don't want to be trying to take a test and see, oh, this one I have to put the square root in after I put the number in, or do I put it in before? You don't want to have to be figuring that out while you're trying to take a test. Okay, so just something to keep in mind. You might just pick up something. Usually you can get a scientific one for $12 or less. Do you know that? Those TIs. I know one of my kids got a TI 30X something or another. I don't remember the number. But anyway, it wasn't very expensive. Okay. What other questions do you all have? Anybody have any other questions? Okay, so let's look at the Mymathlab site for just a moment. Now, so we understand that we can just get the Mymathlab code, right? We can just get the code and use the online book and materials from there. Or you can buy the textbook. The textbook new comes packaged with the code here at the bookstores and so forth. If you like to have the actual textbook, and that's a good thing too, that's up to you. But let me go over here to Mymathlab and just show you a little bit on the site for a moment, because I would like for you to get registered on that as soon as possible. I expect not everybody will be registered by next class, I would guess, but hopefully within a week we'll all be registered on there, okay, so that you can work on the assignments that I'll put there. Right now I don't have anything set up for you just yet. But I am going to show you how to get to the textbook in case you go ahead and get registered and you're planning to use this textbook. Well, I thought I was. It's actually not coming up on this. I don't know why. Oh, well, we saw a glimpse of it. Well, that's strange. Normally it comes up with that page that we had to blink and see real quick, you know, and it allows you to register and so forth. I am not sure what's going on with that. So it's either, well, it's probably their website problem or something, but we'll check into that. Anyway, if you go, I know it says all this Pearson, MyLab, and Mastering.com. If you just type in mymathlab.com, it gets you there. It's a lot easier to remember. And that brings up something else, though. If you had a code and used your code for Precalculus within the past year with this same textbook, it should still work. Okay, so don't go buy a new code. If you had this class or used Mymathlab within the past year, or maybe you had the first part of the class and used a code for that, you do not need to buy a code in that case. If you have trouble getting on with it for that, let me know and I'll try to help you through that process, okay? There should be a place on there, though, if that is you, there should be a place that says add a new class or something like that. And you can go in and put in our new course ID, the one from the syllabus here. I also have the course ID here on the news on our front page, okay? Right here under Mymathlab. So there's the news there, okay? Any questions about getting onto Mymathlab? All right, good. Okay, so on our D2L site, that's where I will put any types of handouts, anything like that that I want to give you. It will be on here. I have a few here under handouts. A unit circle, blank unit circle, trig formulas. I may or may not add more, but those are there for your use. We'll be getting to those pretty soon, okay? All right, let me go through the roll and see if I can say the names. That sound interesting? No, I want to make sure I pronounce them correctly. You know, sometimes I may not say your name correctly when I read it up here. Get a pencil here. Sometimes I have to make notes so I can get your name. Plus, I want to be able to call you what you want to be called. You know, this is a small class overall. I have another pre-cal class, and it has 72 students in it. It met yesterday, so this is much smaller, more manageable here, right? Let's see who's here today. If you'll just answer for me and press that button and tell me you're here, okay? Jonathan Beck?
Present.
Okay. Douglas Concannon?
Here.
Okay. Okay, let me try here. What's that?
Is that Amelia Kukalowska?
Yes, Amelia Kukalowska. Is that close? Okay. Thank you. Thank you. Brandon Delgado Adame.
Here.
Okay. And y'all feel free to correct me, you know, if I mispronounce or if I call you something you don't want to be called, let me know, okay? Thomas Ellswick. Okay, and you know there's a button back there that you'll have to push so that the people over there can hear you. Do y'all have a button back there? Oh, so next time you might want to sit over here. Okay, you're fine though today. I thought there was one back there. And call you Tommy? Tom, okay. Thank you. I guess you didn't have a button. So, Juan Gisbert.
Here.
Okay, thank you. Jamie Kinchlow.
Here.
Okay. Sydney Lawson.
Here.
All right. Aaron Maher.
Here. And
That's just
Mayer, okay. I didn't know if I had to pronounce the H there. Thank you. Rachel McCauley.
Here.
Okay. Larry Moore.
here.
Veronica Morlock.
Here.
Cheyenne Mullins.
Here.
Okay. Michael Mullins. Grady Peters.
Here.
Okay, thank you. Jacob Porter.
Here.
All right. Jonathan Pritchett.
Go by chance.
Chance, okay. Brent Rathbone.
Here.
Okay. Evan Riley.
Here.
Okay. Gerald Rivers.
Here.
Okay. Stephen
Scheidler.
Scheidler, yes. Thank you. Kyle Seavey.
Here.
All right. Zachary Silman.
Here, I go by Zach.
Okay, Zach, thank you. Austin Skelton.
Here.
Okay, thank you. William Thacker.
Here.
Okay, thanks. Jonathan Wright. All right, and Thomas Zaleski.
Here.
Okay.
I go by Tom.
Tom, okay. All right, those are the names I have on my list. Did I not call anyone's name? Is there someone I've left out? Okay, I got everybody's name. That's great. All right, so I said we would talk a little bit about some algebra concepts that I hope that you would know coming into the class, okay? So I know that as a prerequisite, that first part of the textbook is not listed, I don't think. It's just a knowledge of algebra, or at least 2 years of high school algebra, that sort of thing. For some of you, that may have been a while, okay? For all of you, actually, that may have been a while, because now we have that block scheduling going on in a lot of high schools, and so maybe you take algebra, you know, well, probably most of you take algebra your 8th or 9th grade year now, and so even with that, you know, hopefully you've taken math all along, but I think it was just, well, you all are in a group, if you've just come out of high school, and in Tennessee at least, you've had to have 4 years of math, right? I think that's the criteria, 4 years of math. Okay, so that may work out better for you there, but still the block scheduling, I don't know, it squeezes the concepts in pretty quick. So I'm not going to do a lot with this, but here's some things I would think that you would know coming into the class, okay? You need to know the order of operations. That's not really algebra, that's from way back. That means, you know, which order do I do problems in, parentheses, and then exponents, and, you know, multiplication and division at the same time, but in order from left to right, and addition and subtraction in order from left to right, okay? These are review concepts. These are things I'm assuming you know coming in. You need to know how to work with everybody's favorite, fractions, okay? You need to be able to solve basic equations. You also need to be familiar with linear equations. You know, and things like picking out the slope and y equals mx plus b, those sorts of concepts, okay? You need to be familiar with radicals. We use radicals quite a bit in here. Square roots especially, we'll see a lot of. And what else? The other favorite, factoring. Factoring polynomials. So these are some of the key things that hopefully they at least, sound familiar, and hopefully you remember how to do these things. Now, I couldn't get the Mymathlab part to pull up, but when you look on the Mymathlab over it, there will be on the left side, that's kind of where your little menu board is. There'll be chapter contents, and under chapter contents, there is an algebra review section. So if there is a topic that you feel like you need to review a little bit, there's a good place to go and look for some of the review items on that topic. So just kind of as an overview here of this sort of thing, for example, with radicals, if I want to simplify the square root of 12 without a calculator, what do? Yeah, it's 4 times 3 because I'm looking for a perfect square number that can multiply by something else to give me that value. And that's going to give me what then? 2 square roots of 3, right? So you remember that sort of thing. For the factoring, if I have something like x squared minus 16y squared, how does that factor?
It'd be x plus 4y times x minus 4y.
That's right, x plus 4y times x minus 4y. If I have x squared plus 9x plus 18, how's that trinomial going to factor? Anybody remember that? Well, we know the first terms have to multiply and give me the first term here, so it's got to be x times x. And when it's just 1x squared, then the last terms have to multiply and give me this number here, but at the same time they need to combine and give me that middle term. So I'm essentially looking here for factors of 18, numbers I can multiply together to get 18, that will combine through addition or subtraction and give me that middle number 9. What would those values be? It's going to be 6 and 3 because 6 times 3 is 18 and 6 plus 3 is equal to 9. Okay, all signs were plus up in my trinomial, which means all signs will be plus here in this case. Now, most of you probably do remember multiplying that thing back out. Do you? Remember multiplying it back out? So we would say, some of you called it the FOIL method, first, outer, inner, last. Remember the FOIL method? Okay, so the first terms, I just look at it as the distributive property. I'm taking the first term in the first set of parentheses times the first term in the second set of parentheses. That gives me x squared. The first term here times this other term over in the second set. It's distributing the values. So plus 3x. Then I'll go to this second term here, the 6, times the x and times the 3. So plus 6x plus 6 times 3 is 18. Here's where that 9x came from. So in math, we do a lot of things forwards and backwards. We'll do it forwards, and then we'll come back and do it backwards or undo it. So in this case here, the forwards part we actually did last, where we multiplied the two polynomials together. The factoring is kind of the undoing of it. Now, again, in the first part of the textbook, we don't necessarily teach these concepts, but they are put to use a lot more as far as to strengthen your abilities with those, okay? Because again, these are things that we think you already know, okay? So I'm thinking you already know this stuff. If you don't, you might need to tell me when we're doing something that involves them, okay? Or go to the algebra review, one or the other. All right, so here's some things we have. Let me give you one other review type, something to think about here. 14 divided by 7 plus 4 times 2. What's that equal to? 10. I'm getting 10s over here. Is everyone getting 10? So this is the order of operations. There are no parentheses. There are no exponents. So I go right away to do multiplication and division in the order that they occur from left to right. So I'll be doing this part first and get a 2 plus this part here gives me an 8. So 2 plus 8 is 10. Okay? We all right there? All right, we got to be careful with things like that, though, because we can all come up with different answers if we don't follow the rules. Okay, we've got math rules. So we have to follow those rules. Also, we'll be working sometimes with some negative values. Mostly in here, though, we're working a lot with angle measures. That's where we start out with, is angle measures. So we are going to have time to talk a little bit about the first part of Chapter 6. Angles and their measures. And again, this part will probably be review for you, especially if you have ever had geometry. Okay? So we already said that Chapter 6 is called Trigonometric Functions. Okay, so it's kind of our introduction to the trig. So we want to first just make sure we remember the angles that you have probably seen before. Angles, first off, are formed by two rays. A ray looks like this. Okay, that's a ray. Whenever we put two rays together, we form an angle. So this is a ray. This one's what? A line. What was that one? Whoops. Pretend they're all straight. Okay. Yeah, this is just a line segment. Okay, just a little synopsis there of what we have. When I put two rays together, I form an angle here. When I form an angle, this part where the two rays connect with each other is called the vertex. Okay? And we're measuring the angle right here, on this part here. That gives us our angle measure. Most of you have probably measured angles with degrees, I'm guessing. And used what type of instrument to measure? A protractor. Okay, so a protractor is used to measure angles. You won't have to be using one in here. Okay, we're going to work with some basic types of angles more than anything. We don't have to actually measure them ourselves. But one thing we know about angles that are less than 90 degrees, what are they called?
Acute.
Acute. So this one I just drew, that appears to be less than 90 degrees, doesn't it? What does a 90-degree angle look like? Yeah, it's like this. So a 90-degree angle forms what we call a right angle. If the angle measure is greater than 90 degrees, what do we call those? Obtuse. So we're just getting some of our vocabulary back about angles, geometry. Y'all probably remember this. Are you remembering? Yeah, it'll come back, right? It'll come back to you because these are not words, though, that you may have used every day. All right, so when we talk about just some more types of angles here, angles that add to equal 90 degrees are called what? Complementary. Okay. Angles that add to equal 180 degrees are called supplementary, right? So again, just putting some terminology out there. I heard a while ago something about a right triangle. A right triangle has a right angle in it, so that's why it's a right triangle. So right there we designate the right angle with the little box in the corner. So this is a right triangle. And any kind of triangle the angles in any triangle add up to, what do they add up to?
180.
180. 180 degrees. Okay? The angles in any triangle add up to 180 degrees. Okay? So 360 degrees, I heard something about that now too. And 360 would be all the way around a circular measure there. Okay? Yeah, or in a square, the angles would add up to 360 degrees. That's true. When we think of 360 degrees, though, we start thinking more about circles, don't we? A little bit about going like this around the circle, okay? The angles that make up those, the central angles of that circle, okay? And we're going to focus on those a little bit more in this section, or in this chapter, actually. Maybe not in this section, but in the chapter. Are we okay so far on our terminology? Good. All right, so another thing, a while ago when I drew this angle, that first acute angle I drew, we want to note that we measure from the initial side, this is my initial side, up to the terminal side. So these are just some words we may be using in here, and so I want you to know what we're talking about. The initial side is the starting side where we measure up to that terminal side, okay? Also, when I have a straight line angle, where I measure from here to there, how many degrees is that? 180, right. So that's what we call a straight angle. So when we measure in degrees, you know, 1 degree is going to be 1/360th of a revolution. If we talk about a revolution around that circle I was indicating a while ago. So let me draw up something about a circle here for us. First off, I'm going back to an XY axis. Then I'm going to draw a circle. Now here's where you've got to really pretend, okay? You got to really pretend that that looks like a circle. What's wrong with it? Well, a lot of things are wrong with it, okay? It's not really a circular shape overall. We're going to pretend that's a circle. We're going to pretend that the center of the circle is right there in the middle where the 0, 0, the origin is on my XY axis, okay? So that's what we're going to pretend here. So that's my center, my circle. That doesn't look so great, but anyway. When I talk about a central angle, this could be a central angle right here, okay? A central angle will have its vertex there at the origin if I'm looking at this, or in the center of the circle, okay? Maybe even if I don't have my XY axis drawn, the central angle will have its vertex there at the center of the circle, will be its vertex. Now, so this is an angle I've just placed in here randomly. What this angle does is it zones off what we call a sector of the circle. So maybe before when you were in elementary school and you learned about fractions and they gave you little circles divided up into pie-shaped wedges, right, like this, you were really looking at sectors and not pieces of pie, okay? All right, so that's what a sector of the circle is equal to. Now, we can find on this circle, we are going to be able to find the arc length here. The arc length zoned off by this sector is where I'm putting kind of a little dashed part along the edge of the circle. You know, because that's curved, so that's not a straight distance. But, you know, if we had a circle drawn out, we could lay a string on it, something that was more flexible, and get the length of that arc there that's formed by that sector. So we are going to be able to find the length of the arc that's formed there. We call that the arc length. We're going to also be able to find the area of the sector of that circle, or the space inside that sector here in this section. And we're also going to learn about radians compared to degrees, how we measure with radians versus degrees, okay? when you go into calculus, you use radians just about all the time. So we want to be familiar with radians. Most of you have studied degrees before. Radians might be a new concept for you. I don't know. So let's see how that goes. Let me start out just a little bit here with degrees. So for example, we had mentioned a while ago that this would be all the way around here would be 360 degrees. Right? 360 degrees there. So what I'm going to also let you know today is that 180 degrees is equivalent to pi radians. That's going to kind of be our basis for what we're looking at here. 180 degrees is equal to pi radians. You can remember that. You can get this radian concept, I think. 180 degrees is pi radians. Well, what would that mean then that 360 degrees is? 2 pi radians. All right, so lots of times you all have talked about, in previous classes that pi is approximately 3.14, pi is 22/7. We can leave it in terms of pi, okay? In a lot of cases, and what we do in here, we'll just leave it in terms of pi. That'll save you some of that calculator usage on the first test, won't it? We leave some things in terms of pi. Now, later on, depending on what we're working with, we may want to actually use that pi key on our calculator to figure out a more exact answer. But pi is actually the more exact one. The other one would be more approximated answer. But it might make more sense to us sometimes to get the approximation instead of using pi. All right, so I'm going to draw a new circle. Let's see how this one looks. It didn't join back up. Center of the circle, okay. We know that this is where I'm going to say 0 degrees because that's going to be my initial side, just right across there. If I come up, straight up, now I've measured off up to 90 degrees, right? I'm going to put it up there because I might want to draw some more angles in there, some more rays to connect, okay. If I were to come, okay, that was 90 degrees. If I were to come all the way over to here, we know that we have gone 180 degrees. This one where the 0 degrees is, that line out there, that's always going to be our initial side for any angle we work with. I'll tell you today, that's going to be our initial side. That's our starting point, okay? When we come down here a little further, how many degrees am I at now?
270.
270, good. And then we said a while ago if we go all the way back, now we're at 360 degrees. And it's hooking back up at the same place where I'd written 0 degrees, right? But now I've gone all the way around. Instead of at 0 degrees, I was just starting, but now I've gone all the way. Now, we said that 180 degrees is equal to pi radians. I'm putting it back on this page here. And 360 degrees is equal to 2 pi radians. So let's fill those in. 180 will be equal to pi radians. 360 we said was the same as 2 pi radians. I'm just writing those off to the side there. 0 would be the same as what? How many radians would 0 degrees be?
0.
0 radians, right? 0 radians and 0 degrees. If I'm talking about degrees, I want my little degree symbol up there. That way I know it's degrees. If the degree symbol's not there, then I must be talking about radians. Okay? Just to get those ideas straight. Now, here's where we got to think a little bit more. If 180 degrees is pi radians, what is 90 degrees equal to? 1/2 of pi. So we usually just write that pi halves. But you're right, 1/2 of pi, 90 is 1/2 of 180, so 1/2 of pi is equal to pi halves radians up there. And likewise, this 270 degrees down here, what's that one going to be? 3 pi over 2. Some of you have done this before and are familiar with this, right? So it's 1.5 pi, essentially. 1 1/2 pi. We'll write it 3 pi over 2, or 3 pi halves. Okay. We're going to have other places inside here that we also want to know about, some other angles. Especially in this class, we're going to be interested in the 30-degree angle, the 45-degree angle, and the 60-degree angle. That one got a little crooked there, but anyway, 30, 45, and 60-degree angles, and all the ones that correspond to those all the way around that circle. Okay? All the way around. Now, these we might have to think a little bit more about also, but here's how you can think about this. 30 degrees is what part of 180 degrees? 180 divided by 30 is?
So 1/6.
Right, 180 divided by 30 is 6, so it is 1/6 of 180. So 30 degrees is equivalent to 1/6 of pi, or pi over 6. It's 1/6 pi. There's a 1 understood there. You are with me on that, right? There's a 1 understood there. Everybody always loves the things that we understand in math. Yeah, it's understood. We tell you that anyway, right? Okay, so it's 1/6 of pi. What about that 60 degrees? I'm skipping 45 right now. What about the 60 degrees? How much of pi is it?
So 1/3.
It's 1/3. So it's going to be pi thirds. Now, 45 degrees is what part of pi? A fourth. So we've got some little fractions going on here, right? To get us started there. 1 degree, in general, is equal to pi over 180 radian of a radian. Okay, that's a fraction of a radian there. 1 radian equals 180 over pi degrees. I'll do it like that, okay? 180 over pi degrees. Because of those things, we can write out some formulas to convert degrees to radians and radians to degrees. So I will put those out here because you might need them for some of the other angles. But these like this, 30, 45, 60 degree angles, those we can see what fractional part that they would be equal to. But what if it was something, you know, like something random, like 32 degrees? Okay, 32 degrees doesn't fit so nicely with the 180, does it? No, so we might need some sort of formula or want to use some sort of formula. So let me put our formulas down here. If we have degrees and we want to convert to radians, then we'll take the degree measure times pi over 180 to give us the radian measure. Okay, the degrees times pi over 180 will equal the radians. If I have radians, but I want that in degrees, then I would multiply by 180 over pi to get the degrees. So there's lots of times we'll see pi involved with those radians. Okay, not always, not always. I want us to think just a minute about, you know, this might not look like a lot of information. It's actually a lot of information here. When we are going over to pi radians, since you already know that pi is approximately 3.14, you know, that means this is approximately 3.14 radians. We don't normally use this, so you don't need to write this part really, but we know that pi is approximately 3.14 radians there. But that might help you understand a little bit if you're talking something about an angle that's 1 radian. Where would an angle that's 1 radian be? We don't know exactly maybe right now, but where's it going to be? Close to what? Okay, so probably over, probably over close to the 60-degree angle, maybe somewhere in here, maybe, because then we'd still have, you know, 2 radians. So we got to kind of split it up, right? And then 3.14 coming over there, something like that. But if we want to figure it out for sure, you know, we see 1 radian is going to be 180 divided by pi. And a good estimate is 60 degrees, isn't it? 180 divided by approximately 3. So that works in there. Now, just to get our head wrapped around this radian concept, because we will see angles that are like 1 radian, 2 radians, 1.5 radians, something like that. The measurement's a little bit different. But we want to keep those measurements in mind. Now, if I come on around the circle, you know, we could keep labeling these off here. It's going to get a little messy, though. All right, so I've got my 30, 45, 60. Let's just work with the 30 and 60 for a minute. I've got 30, 60, 90. What's next? 30, 60, 90.
120.
120. After 120, skip that one in the middle. 120 would be 150. We're just going every 30, right? And then 180. Okay, so that's dividing that top part up. Let's go on down here. I'll just skip over the one that would correspond to the 45 because the 30 and 60 degrees kind of work together. Okay, so after 180, 30 more than 180 is what? 210, 240, 270, 300, 330, right? Okay. What about in radians then? I want you to look at our radians that we already put up here for those. That one, this one, whoops, this one. All right, pi 6, pi thirds, pi halves. Those all have different denominators, but let's look at those again. If we start counting off, this one is really 1/6 pi. This thing up there was really 2/6 pi, and we just reduced it to be 1/3 pi, right? So 1/6, 2/6. This one was really 3/6 pi. So this next one must be 4/6 pi. What's 4/6 pi reduced to?
2/3.
2/3 pi, right? And then we've got 5/6 pi. And then 6/6 pi is just pi, right? So the next one's 7/6 pi. You're all seeing this pattern here? 8/6 pi, which is really 4 pi thirds. This one down here is really 9/6 pi, but we reduced it. 10/6 pi is really 5 pi thirds. 11/6 pi, and then 12/6 pi. We just counted, didn't we? 12/6 pi is really 2 pi. Okay, we want them in the reduced form, but you could count around there, you know, 1/6, 2/6, 3/6, all these in increments of 30 degrees. That's how we get there, okay? We'll do the same thing next time with the 45-degree ones, okay? But not just yet. Any questions so far? I want you to do something for me real quick to give to me. And this is just a little background knowledge for me to have, okay? So first off, for next time, if at all possible, go ahead and get on Mymathlab. If you can't yet, that's okay. We'll get it there soon, okay? I understand there's always some financial aid coming through, difficulties, things like that, but just as soon as you can, all right? That's what I want you to think about doing. Go back over the things we looked at today. That would be good too. What I'd like for you to do, though, now is before you leave to give to me, okay? It's not a grade. It's just some information I need to collect from you, okay? Just so I know a little better where we're at. First thing I want to know is, of course, put your name on it, okay? So I know who you are. Secondly, second thing I want to know is tell me the last math class you took. And here's the clincher. And when. Now, don't say senior year in high school because I don't know when that was. Give me some idea of time frame, okay? Don't just say it was my senior year of high school. Well, all right, it wasn't. If it was last year, that's fine. Last year tells me last year, right? Okay, that's good. But if somebody says senior year of high school, it's different for lots of you. I don't know when it is. So the last math class you took and when it was. And then thirdly, why are you in this class? Everybody's here for some reason or another, right? This is not a gen ed course, okay? Nobody made you take this class, did they? Oh, yeah, some departments do make you take it. But tell me that if that's why, okay? You don't have to have long answers. Just give me a short answer, okay? And just, if you will leave those on the back table as you walk out or leave them with over there in Kingsport and David will get them to me, that would be great. Any questions before we go today then? You all have a great day, and I'll see you back on Thursday then, okay?